So now what we're going to talk about doing is writing a program to milling out a rectangular pocket and a circular pocket. So I'm going to go into the program mode. So the first functions are entering program numbers. There's a few different things you can do here. Is randomly you see that question mark crop up. If you hit the help key, there's a keyboard there. It's kind of painful to walk through. There's also a PS2 port and another USB port here if you want to plug in a keyboard. In the general programming options, you have a few other selections to choose from if you wanted scaling or shrink factor. So if you need to build a mold to make this component here, this material is going to shrink so many thousandths per inch, so you may need to scale that by so many thousandths per inch. Okay? So you can scale up or down 10 times in 2/10 increments. So if I knew this material shrunk at a rate of 5 thousandths per inch, I would enter 1.005. So every time it moved 1 inch, it would move, I saw 1 inch, so it would move 1 inch and 5 thousandths. So you get a slightly larger mold. There's no auxiliary functions. You can choose to write event comments into a program. Have multiple fixtures if you had multiple vices on there. And the dimension definition is always going to default to part geometry. So when you're programming in conversational format, giving it the blueprint data, the tool information, the finish cut information, you always want that to be in part geometry. The only time you'll change that and go to toolpath would be if you were importing a 3D surface file and doing more of a G-code format. So I'm going to go to the beginning of the program, and then here's our event types. Wouldn't you know we're in 2-axis? Okay, so I guess mistakes are a good thing. So the machine booted up in 2-axis. So it's only going to be able to be programmed in X and Y, and I'm going to have to lug around and do the hard work, so I really don't want it. I want it to run on all 3 axes. So at this point here, I have to hit the system key, and then the go to 3-axis function. That just changes the format to X, Y, Z. So now the program is going to change by asking me to enter X, Y, and Z information, whereas when you're in a 2-axis format, it only asks for X and Y. Okay, so here's a little first page of your event types. A little brief synopsis of each one. So a position event would be nothing more than entering an X and Y location and how high up you wanted to travel on Z. A drill event is going to be a pecking routine if you're going to drill some holes. When you select that drill event, it has a drop-down menu that's going to ask you all the questions you need. Bolt hole routine, so you can do an array of holes around a round circumference. You can mill any individual segmented line, straight or angular, in X, Y, or Z, or all 3 at the same time. You can do any segment of a radius less than a full circle because we have can cycles that do those routines. So in this case here we have pockets, and pockets can be circular, rectangular, so we have a lot of different shaped pockets. So let's just stick to the basics because what we're going to do here is just this rectangular pocket. So I'm going to select that first, and that's the complete series of questions that need to be answered in order for the tool to calculate how to sweep that floor, rough that, finish that. And so the first prompt is for the X1 and Y1 to the corner. Well, you say, well, which corner? Any corner. You select which corner is the first one. All right, so in my case, I'm going to say this is the first corner because I know it's 750 typical X and Y to that corner. So 0.75 on X as an absolute, and negative 750 on Y as an absolute. Once I know this corner, the only other corner I need to know is the third. So no matter which way you decide to mill the workpiece, if this is the first corner, that will always be the third. So I'm going to give it the dimensions. On X, 1.5. Now in this case here, this happens to be an incremental value. It's not represented from absolute, so I can just enter it with the incremental key. And the same thing on Y, negative 1.5 incremental. So the next prompt is the radius that you want in the corner. Well, if the tool is going to generate the radius, you would ignore that and just press send. But you can put any radius in this corner that's larger than the tool, as long as it can fit. So it says 0.375. So before we talk about the corner radius, Rich needs to read the prompts. You'll have some editing to do. So the prompt is now asking me about Z. So the top of your workpiece is always Z0. Like I said earlier, everything above the part is positive, everything removing material is negative, and it wants to know where I want the tool to wrap it down to. So the prompt is Z rapid, so maybe plus 100 thousandths. So it will wrap it from up here, go to this point here, and then go into a feet. And then I'll give it the final depth of where I want to end at, and maybe I want to end at minus 0.2. And now it's asking me to input the radius value that I want in that corner of 375. It's asking for the direction of cut, whether I want to go around this workpiece in a clockwise or a counterclockwise direction. And so for machining like this here, you generally want to go in a counterclockwise direction when you're on the inside of a workpiece so that you're fine. So in that case there, the tool is going to be going around the workpiece this way. The number of passes coming down that 200,000 step to cut, well, you might, want 2 or 3 or 4. You just construct it based upon the depth of cut. It'll ask how you want to enter the part. One is a zigzag ramp, so it will ramp in X and Z. Or 2, it'll just plunge straight down. So I'm going to select 1 for the ramp. I'm going to ask it to have a finish cut of maybe 20 thousandths. And then it's all about the feeds and speeds. So I want this particular cutter to travel at 2,500 RPM. Maybe feed at 3,000 RPM at the end. And then it's about the feed. So feeds and speeds are going to be based primarily upon the material. And in aluminum, we might cut at 10 inches a minute for Z, 15 on X and Y to rough, and then 20 to finish. And then I have to identify a tool number. Well, this is the first tool, so I'll tell the tool number. So when you're in the program mode, you can press the look key at any time, and it will display your datum and where the rectangular part is. I press look again, I'm right back to programming. So now I want to do this circular pocket. Select the circle and identify where the center is. So the center is over at 4 inches on X and down 1.5 on Y. So negative 1.5 on Y. And now again, all that Z information, so we'll enter that the same as before with plus 100. We'll go to the same depth with negative 200. And the radius is a 1/2 inch. So it's going to make a 1 inch pocket. We get the direction of cut. When you're on the inside of a shape, preferably go in a counterclockwise direction. And again, that's declining. The number of cuts coming down that 200 thousandths, again we'll tell it 2. We want a zigzag ramp. And then we want to add the finish cut as well. And then it will carry over the RPM from the previous, so the feeds and speeds from the previous event. So as long as the material, the tool hasn't changed, you can just press set to load those features in. And it will use what was on the previous page when you press look. So there's your circular part. Okay, so for the time being, that's the end of the program. So mode takes me out of the program mode. I can jump over here to setup, which is going to be identifying information about the tool. So the tool table needs to know the diameter, where the tool is on Z, things like that. So I'm going to simply come over to the workpiece. Drag my head down. And I'm going to simply tell it that that tool is a 1/2 inch in diameter. It wants to know where the top of the part is. So this column here represents the difference in the length of parts. Length of tools, I'm sorry. So on Z, the difference between here and here. So you'd physically go through and touch off your tools if you had multiple tools. And down. Next to the top of your part, press set, and it registers the location of that tool. This column here will allow you to modify that tool up or down in small increments. So once we've completed this part, if we wanted to remove a few more thousandths, we could just give this a very small adjustment of negative 2 or 3 thousandths. It'll just remove a few more thousandths of it. It'll also ask you for the tool type, so you can identify your tools. That is a finish end mode. So it'll instruct you what type of tools to load, when to load. If you have other additional tools in the program, we'd have to go through this routine. But if you notice, only tool 1 is in red because that's the only one that's active in this program. Alright, so now we can show the tool path. And so you can quickly get a little idea there of, well, I've got pockets, and one's rectangular, one's circular. I don't know a lot about it. But the tool path will allow you to view it and get an idea if it's going to accurately cut the part. So when you press the step key, it shows dotted red lines as rapid moves. Those are moving at 150 inches a minute. And then the solid blue lines as feed. So this is removing material. So you can see there's your second cut. And then you have a third cut, which is the finish cut. And then it jumps over and it starts to mill the circular part. There's one more page here in the setup mode for reference positions. And that's setting the location for the head to retract to. In fact, if I exited this and never completed this, you'll notice that you still cannot run the machine. So we have to complete that command. So back to setup, reference position, set Z retract. So just move the head to a desired retract. So you can activate the jog key, jog the Z up. Give yourself plenty of room to work around the machine. Press set. So that's displaying a 3-dimensional view. If you wanted to see just the top view, there's your X and Y, but you're not getting that Z depth. Looking at an XZ can be handy because if I adjust that and zoom in, You want to make sure that when that tool rapids from the rectangular pocket over the circular pocket, it's above the part and not down below. So that dotted red line represents a rapid. Okay, so now when I press mode, go back to the main menu, I've got the run function active. So I'm ready to make the part. So when I press run, comes up with the start key, which is going to start at the beginning of the program. The start and event key will allow me to start in the middle of the program or do a trial run, where Z stays stationary and it only moves X and Y in a round. So I'm going to press the start key. Ready to begin, press go when ready. Well, when I'm pressing go, I'm losing control. It's going to rapid at 150 inches a minute. And if I'm not quite comfortable what it's going to do, we've added this tracking software function. So when you select tracking, and you should at the beginning of every program, it allows the machine to sit parked there, and I can turn either hand wheel, and it will follow the program at the speed I turn the hand wheels. Okay? So I'm in control. So it's moved back to its home. It's instructed me to put in the 1/2 inch finish diameter, end mill, turn my spindle on, and press go. I'm still in tracking. So the nice thing about programming with the ProtoTrack system and you're using conversational events, the ProtoTrack knows how to position the tool to make that rectangular part. It knows that the tool needs to stay retracted until the machine moves into position on X and Y. Then it will read your Z rapid, that plus 100. Then it will read the Z ending with that difference. Then it will start to mill the pocket. And it will do that in reverse when it goes from the rectangular pocket to the circular pocket. It's going to complete sweeping the floor on the rectangular pocket, retract up without moving an X and Y, rapiding over to the beginning of that circular pocket before actuating the signal. So you can see it comes dragging down. And I can see a little location here where, well, it says it's at a 1/2 inch, 550,000 feet. And I'm not touching the part yet. So I've left out one step. So before I go and run it, you have to go in digital readout mode, and you have to identify where the workpiece is by touching off your tool. And establishing your Z absolute 0. So you want to make sure that it pulls all the way up and you tightly lock it. So go back into the run mode again, press start, select that tracking function. And again, it's going to go back to your home position. Instruct you to load the particular tool. Turn the spindle on. You control the spindle on. It never turns on automatically. It will only shut off. So I can look at a combination of my readout to see that I'm at plus dimension and start to remove some material. And once I feel confident that things are going well, I can hit the stop key. That brings me to a point where I can change the screen and go from the tracking function to CNC run. And now the doors need to be closed. So when you're in that automatic mode, the doors must be closed. to go back to the tracking function again. I can hit the stop key. Go back to tracking. Control that by hand. Just put a little bit of coolant in there. So I can control the cut again. We'll select the stop and go back to automatic. So now it changes the RPM to do the finish cut. Retract to that plus 100 and then start to feed down for the circular part. Completes the finish cut, I'm going to automatically go back to a Z retry, shut the spindle off, go back up. So I guess at this point I can determine if my part's accurate. So I should have a 1-inch dimension here. And I'm at about 994. 996 of them. Here it should be at 1.5. And I'm about 4 thousandths under there. So there may be a few things. There may be a little bit of deflection left in the tool. Maybe the tool's undersized or oversized. That's a little bit oversized. So I can do a couple of interesting things here. I can go back into my setup mode, and when it comes to the tool table, I can simply come to that tool size, and if I want to remove a little more material, I tell it the tool is small. It doesn't go quite as far away to offset. So if I told it that that tool is now 498 thousandths, it'll take another thousandths per cell, because it's going to offset 249. So just quickly review my tool path, make sure that everything still looks good. When I go back into run, instead of starting at the beginning, which is going to start with all the roughing cuts, I can instruct it to start at event number 1, and it will say you want to start with the rough or the finish cuts. So I'm going to just jump right into the finish cut. Ready to begin, press go, but again, I've done some modifications. I'm going to go into tracking so I can control what it's going to do. Spindle shuts down automatically and shutting off the tool. So maybe what we'd like to add to this is a second tool that's now going to do an array of circular bolt pack. So when I go back into the program mode, I want to into the program mode, and I want to do this at the end. So it takes me to the next open event. I call it a bolt event, bolt hole event. And so it wants to know if I'm drilling, boring, or tapping. Well, I'm drilling, and that selection is 1. So the number of equally spaced holes, 1 to 99. Well, typically you have 6 or 8 or something like that. You have to identify the center of the bolt pattern. So that's again 4 inches on X, 1.5 on Y. So 4 inches on X, negative 1.5 on Y. And now it's about identifying the rapid, the depth of the hole. So rapid to plus 100, so that's above the part. And then drill the depth to minus 250. And it wants to know the radius of this, so we'll tell it maybe a 1-inch radius, so a 2-inch bolt pattern. The starting angle, so a bolt pattern always sees 3 o'clock as 0-degree datum, so it'll put the first hole over here and measures angle in a counterclockwise direction. So you're just orientating where you're starting that bolt pattern. So I'll tell it to start at 0, which is 3 o'clock. Then you have your peck drilling routine here, where you can tell it 3 or 4 pecks, the RPM, maybe 2,000, the feed rate, and then a tool that's going to be different than this half-inch end mill, so tool number 2. Nice, I'm going to remove this, making sure that that's locked. Line up those tabs again. And then put that drill. So here's where you'll use the brake is to hold the drill chuck and you tighten that drill. Okay, that's really the only time you're going to use it. So I'm going to go into my setup mode. Go to my tool table, and I now have to tell it information about tool number 2. So when I'm not making entries, I use my data down key and my data left key. So that's a 201 thousandths diameter drill. I have to set the difference between the lengths of tool 1 and tool 2 by coming down and touching the same location that I set that first tool. So I come down and touch the top of the surface, press set, and it enters the value based upon where tool 2 is. And I can tell that it's a drill. Now when I hit return and select the tool path, now you'll see if I adjust that and zoom in, now you have that peck drilling routine as well. So that's page 3. So at this point here, I just want to start running event 3. So when I go into the run mode, press the start an event key, so I'm starting in the middle of the program. Start at event number 3. Ready to begin, press go. Well, I lose control, so I'm going to select tracking. Load tool number 2. It's a 201 thousandths diameter drill. Turn your spindle on and press go. Again, in that tracking function, I'm in control. And I can see that I'm about 175 thousandths above the part. I'm going to go to the pecking routine. And peck that hole 4 times. So you have coarse here, and you have fine here. So it moves a little bit slower here. Okay, so I can see it move to the next hole, so at this point here, I'm going to press stop and let it go to CNC run. And again, the door has to be closed. So the interlocks have to be engaged for it to run automatically. Retracts, goes back to home, returns on. Certainly.
Is there anything weighing on the kind of place
It's really more of a machining practice more than it is talking about programming. But a center drill is certainly going to make the location much more accurate before you go and open the hole up with a regular drill. So you should center drill first if you're trying to hold some type of tolerance. Very good. Okay, program storage. So we have this file, part number 120612, that I want to save. So there is a 3.5-inch floppy disk drive, which you guys don't know anything about. Plug in the USB thumb drive. And so this is the last mode of operation, program in and out. And I want to save that file. So I'm in a save mode now. And I just simply hit save file.